Welcome to the genius world of monster engineering!
Each show, we're going to introduce you to 3 geniuses whose ideas have quite literally built the world.
We put all their epic brilliance to the test.
Hit it!
When we tackle our own genius monster build.
Don't you dare demolish this! Going higher.
Why is it swinging?
Faster! And scarier!
All in the name of science.
That is a massive piece of construction.
What could possibly go wrong? On today's show, we're going up,
Down.
it's unbelievably fast, and across.
Go! Come on, McCart! Run! As we uncover the secrets of epic bridges!
Wow. Look at that, it really is a monster build, that, isn't it, eh? This is absolute genius!
From the city over there to the other side of the bay.
Swim it.
What? No, the sharks.
Tunnel it.
That was so ridiculous.
Bridge it.
Who's she?
Don't bridge it.
Oh, Bridget, yes, I see. This is the Golden Gate Bridge in San Francisco.
And today's show is all about, you guessed it,
Bridges! People have always needed to get from A to B, but sometimes there's a big problem,
Well, this is a big problem.
which forces engineers to get thinking.
And the simplest solution, build a bridge.
Bravo.
They're a brilliant fix whenever nature gets in our way.
Oh, that's got it.
As we've become smarter, bridges have become longer, taller, and stronger. Today, there is almost no gap too big to span.
But let's rewind the clock. When it came to genius feats of engineering, the ancient Romans were hard to beat.
From amphitheatres to aqueducts, they knew a thing or two about building stuff that lasts.
We've come to the south of France to see one of the biggest and most impressive examples of Roman engineering in the world.
Yeah, it's such a popular tourist attraction that's even found its way. Oh, pretty good, eh? Have a look, it's amazing. This is the Pont de Gare.
The bridge over the River Gare.
The Pont de Gare has stood in this valley since the 1st century AD.
It's survived everything from floods to gale force winds, and today it's one of France's most famous landmarks.
And there's only one way to visit this magnifique bit of construction.
See you later. It's not a gondola.
Cornetto.
It's not a gondola.
Give it.
Dom, just sit down. Oh, it's even more impressive from this angle.
And if it wasn't for our first genius's massive brain, the secrets to the strength of the Pont de Gare would have been lost.
Introducing author, architect, engineer, and all-round Roman boffin, it's
Vitruvius!
You got my beard all wet.
Yeah, but you've got to dry moustache.
Genius helper Alejandro Mendes Graf has arranged access all areas to this Roman marvel. Hi, Alejandro.
Hi.
How you doing? Nice to see you.
Yeah, welcome.
Be great to have a look around the bridge. And we're starting where else but right at the very top. Almost 50 metres above the valley floor.
Alejandro, it's in really good nick, this place, but how many years old is it?
It's 2,000 years old.
2,000?
What was it built for, though?
This aqueduct was built to have running water in the city of Nîmes.
So this whole construction was made to get water from that side of the river all the way through this, I suppose you'd call it a tunnel, over to the other side so people who lived over there could get fresh water.
That's right.
Wow. The Pont de Gare's 3 layers of arches aren't just for show.
This was the only way that the Romans could build high enough to keep the pipe carrying their fresh water level with the surrounding hills.
We're inside the pipe. You have to imagine this place with water coming almost up to the roof.
Is this tunnel all watertight?
This tunnel is watertight thanks to the mortar, which was on the walls here.
The Roman crushed volcanic rock.
When added to the walls of the pipe we've just seen, it stuck the stones together and stopped the water leaking out.
Clever. But they didn't use it all over the bridge, as we're about to discover. So obviously it's been well put together. How is it actually constructed?
The stones, which are the building, are stones that coming from a quarry up about 600 meters downriver. That way transported up to here. All those big stones are hauled together without mortar.
So there's no sand and cement, no bonding at all?
Not at all, and mainly which concerns the first and second level.
Amazing, but also very strange.
After all, this massive stone bridge weighs over 50,000 tons.
So we understand that the top of the bridge, the aqueduct, is held together with mortar. But what about the rest of the bridge? How does it stay up? What's sticking the bricks together?
There's only one way to find out. Le Fran!
Meet Fran, our scientist friend.
Go!
Who can explain things in a way that even we can understand. It worked, Franny!
She loves a good experiment.
And best of all, she pops up whenever we need her.
Franny, everybody. Hey! Franny, we need your help. The pondagar was beautiful, but the bottom part of it was stuck together with nothing, not a saucy song.
Ah, you think it was stuck together with nothing? Well, in fact, it's stuck together with friction.
Friction? Yeah, but friction slows moving objects down.
It does, but friction can also stick objects together and stop them from moving completely.
Oh.
I want to show you with this stuff.
Ah, right. What are you going to do? Cook us a curry?
Ah, well, I've got a little bit of a challenge for you.
Yes.
I want to see how much of this rice you can pick up just using this stick.
What?
Give it a try.
Well, you go. Go on.
So, yeah, you
Go on, challenge it.
Just in different ways, see how much rice you can pick
How much
up.
rice have you got? Oh, give up.
Silly experiment.
Hey, Franny, why you no use pasta?
What if I told you that using friction, we can pick up the whole of this jar of rice?
That's not possible. You can't use that stick to pick up all that rice.
Well, we'll see.
No.
So, Dick, take this. Just jab the stick in a few times. Just try it.
Jab it.
Yeah, just jab it in. Yeah, and, like, lift it out and then put it in. And each time you're doing that, it's jiggling the rice about in such a way that more and more rice is touching the stick. And eventually there'll be enough rice touching the stick for the friction between them
I say no.
to be enough to lift up the whole of the jar.
I say no.
Let's see, lift it right out. So you've got to lift it right out and then put it right in. And then lift it out and then put it in. Oh, go on, go on.
Oh, look at that! Friction!
Mamma mia, you make a big mess.
But how does that relate to stones holding together a bridge?
Well, what the Roman engineers did is they cut the stones really precisely, so they fitted perfectly together. And that meant there was a lot of them touching each other. Yeah. And more touching means more friction, which means the friction was enough to hold the bridge up without mortar. And the technique is called opus quadratum.
Told you.
And the reason we know about it is because of the writings of Vitruvius.
Now we understand how it was made. The Pont de Gare is even more spectacular.
It's amazing to think that 2,000 years later, that bridge is still standing thanks to the genius way it was built.
And if it wasn't for this man, we wouldn't know how the Romans built it. Vitruvius, you are a rock-solid genius.
Oh yeah, boys, you can't knock me down.
Next.
In fact, they went a lot quiet for nearly 2,000 years.
But from the late 1700s, engineers had cast iron and then steel at their disposal. These new materials set off a golden age of bridge building.
And nowhere went bigger on bridges than New York.
That's That's the Brooklyn Bridge crossing the East River linking Manhattan to Brooklyn.
Yeah, it's a suspension bridge, and when it was first built in the late 1800s, it was the longest of its type in the world.
But without our next genius, that incredible structure would never have been built.
Well, who is it? Don't leave me hanging.
That's exactly what we're doing.
Introducing to you the man who created twisted steel cable.
Twisted steel cable?
Yeah, it's the thing we're going to fly down in a minute at 100 miles an hour.
Great.
Wilhelm Albert.
Happy flighting, Stickundom.
Oh, no.
Stop that. That's silly. We'll come back to that terrifying moment later. Wilhelm Albert was in charge of a German mine. He was fed up by the number of accidents caused when the iron link chains used to haul heavy loads snapped.
His genius idea? A much stronger twisted steel cable, originally known as Albert rope.
Today, Albert's invention can be found on many of the world's most famous bridges, even ones that are still being constructed. Wow. Look at that, it really is a monster build, that, isn't it, eh?
This is the Queensferry Crossing, a new road bridge currently being built over the Firth of Forth near Edinburgh.
When it opens, this 2.7-kilometre span will be the longest three-towered, cable-stayed bridge in the entire world.
That is a massive piece of construction. We've been given special permission to visit the deck where the road will be built once the bridge is finished. Wouldn't want his job. Look at him. Look at him up there. Look at him, his job. Just dangling. Right. Goodbye, everyone.
The deck is suspended 55 metres above the water. That's about the height of 11 double-decker buses.
Whoa.
Oh, hi. Hey.
Hi.
This is the 19th century rail bridge and the 1960s road bridge.
This project is too mammoth for just one genius helper, so we've got two.
Gerard Keeley and Ralph Hildebrand.
So the cables on this bridge, what are they used for?
So what we're standing on right now is the road deck of the bridge, and the cars will be driving across here in a couple of months' time.
Yep.
So to stop the cars falling into the river, these cables stop the deck and they keep it floating in the air.
How much weight will these cables be taking?
In total, all of the bridge deck is going to be close to 100,000 tons, so
Unimaginable.
that's about
Amount of weight.
50,000 two-ton cars. That's quite
A lot.
And it's all thanks to the genius way that these cables are constructed, right?
Correct. On each strand, what we have here, we have 7 wires. You have 1 wire in the middle, and you have 6 wires bended around. And they're holding a lot of force together.
Yeah.
Yeah. So, and in each one of the stay cables, we have between 55 and 109 pieces. 35,000 miles of strand inside, so they can take a lot of load.
But if that was just one central wire and all the other wires around it were just running straight along, it wouldn't be able to carry as much weight, right? It's the fact that they're twisted that enables them to take the massive amount of weight.
Correct.
And this is all down to William Albert's genius. Without him, there wouldn't be a bridge like this.
Exactly. Without him, it would not exist.
Suspension and cable-stayed bridges, like the one we've just seen, can safely carry massive loads over big gaps.
Whilst vertical forces run up and down the towers, Wilhelm Albert's twisted steel cables are being stretched between the deck and tower, creating a
which carries vehicles is locked securely in place. There's no denying Albert's genius, but what better
or scarier
way to put his invention to the test than this? A mile-long zip wire suspended more than 150 meters above a quarry! Oh, isn't he brave? I'm fine, though, because this stuff is strong enough to hold up 100,000 tons of bridge, remember? Oh, hey! Oh, yow! What? That was amazing!
Not doing it again.
It was brilliant!
It was fast.
It's like I mean, just to think, that twisted steel cable was the one thing that was responsible for you not dropping.
All day, my lovely cable. We'll keep you in the air.
Very good. Up to the top again. Come on.
Coming up, go! We're put through our paces
Oh, it's hard work, this.
in a military monster build.
Safe to say.
Push it, push it.
But now it's time for some This London Bridge isn't falling down. In fact, it's gently unrolling. Thanks to nifty hydraulics, this link across the Grand Union Canal can be rolled and unrolled to allow boats to pass.
This suspension bridge in China is paved with 99 panes of extra thick glass. It's 300 metres above the ground, so in case of emergency... Oh, definitely don't brake here.
It looks like something you'd see at a fun fair. But this is the Tees Transporter Bridge in Middlesbrough. This moving gondola can carry up to 200 people or 9 cars. Scream if you want to go faster.
We've seen how genius ideas from the past have helped create some truly breathtaking bridges.
Ah, that's the past, but what about the future? Well, let's meet our next genius.
Mr. Chuck Hull.
Hey, how you doing, boys?
Yes, very well, thank you.
Yes, thank you very much. Yes, very nice.
Back in the 1980s, Charles Chuck Hull was working for a company that put thin plastic coverings on furniture.
In a spark of genius, Chuck tried putting thousands of thin layers of plastic on top of each other before using light to etch the blocks into simple three-dimensional shapes.
Smells ready.
3D printing was born, and now, over 30 years later, it's beginning to revolutionise the way we build.
Gnarly.
The Dutch city of Amsterdam is famous for its canals and is already home to over 1,000 bridges. There's one. See, told you.
Beginning to take shape in this warehouse behind us is one of the newest and strangest of the lot.
Welcome to the home of the world's first ever 3D printed bridge. What?
Huh?
3D printed bridge.
Is it?
Go figure.
What is it? Bridges.
Bridges.
To find out more, we're meeting Tim Gertens. He works for the company who are making the bridge.
Tim.
Hi.
Lovely to meet you.
Hi, nice to meet you. Hi, welcome.
Could you tell us what 3D printing is? How's this machine working behind us?
We have a robotic arm which can move freely in the air, and it squeezes out a little bit of molten metal at the same time. And it's almost like drawing in mid-air. You can just draw lines in the air.
It can move any direction, left, right, up, down.
Anywhere, yeah.
Wow.
Yeah, just
And
like
so
that.
it ejects layers and layers and layers of liquid metal into any shape that you program on the computer.
Yeah, exactly.
Mind-blowing! Tim and his robots have even managed to 3D print a bike frame.
So that whole frame is 3D printed?
It's completely 3D printed out of stainless steel, indeed, yeah.
Wow. Right, can I have a ride?
Sure, give it a go.
OK. Hoi! Oh, it's pretty heavy.
Is it heavy?
Yeah. No brakes?
No brakes, no brakes. No, we
Great.
couldn't print those.
All right, let's see what
So
happens.
what are you going to do?
Gonna cycle
You've
it.
never ridden it before.
Oi! My legs are too short.
Look at that.
It's going very well.
Absolutely solid as a rock.
Yeah.
I like to ride my bicycle.
It's really sturdy. I mean, it's like any other bike.
Is it?
Works a treat.
There's no brakes.
Stop. But it's bridges we're interested in, not bikes.
Of course, your big project is building a bridge. How'd you go about that?
Well, I mean, obviously the robot's not big enough to build a full bridge. So when the robot goes out of reach, we just move the robot a little bit further and then we continue printing.
Wow.
So by doing that, we can print unlimited in size almost. Okay, so this is a bridge that we printed before. It's a miniature version of the bridge we are going to print.
It doesn't look strong enough to be able to take the weight of one person.
Maybe?
Yeah, sure, be my guest.
Oh, it's really sturdy.
Is it not bending on your feet?
No, it's perfect.
As strong as any other.
Two of us got it.
Sure, yeah, you can.
No, it's fine.
Right,
It's really bizarre. It looks really thin and flimsy. But...
All right.
So what are the ambitions for this? Because this is a small bridge. What about the big one?
Well, I mean, the big one's going to be obviously a lot bigger than this one. It's going to be about 8 meters. It's going to be able to support bicycles, pedestrians.
In the future, do you think we'd see 3D printed bridges spanning big rivers? You could put lorries on there and cars?
Yeah, I mean, as I said, you know, it's just as strong as any other stainless steel, so you could print it theoretically as big as you want. But we think your imagination should be your only limitation. So with 3D printing, you can print anything.
The full-size bridge is still a work in progress, but when it's finished, it'll span a canal in central Amsterdam.
But it's been a real eye-opener looking at the future of bridge building.
And none of this would have been possible without the 3D mind of Chuck Hull.
Shucks, you're making me blush.
A 3D printed absolute genius!
Thanks to the three geniuses we met in this show,
That is a massive piece of construction.
bridging gaps that were impossible
Look at it! Wow.
now feel like a hop and a step.
It's time for our Genius Monster Build Challenge.
And we're joining forces with the real deal.
The British Army's Royal Engineers.
Engineers have played an important role in armies ever since Roman times. And the Royal Engineers have been a key part of the British Army for 300 years.
We've come to the home of 3 Royal School of Military Engineering in Surrey.
2,000 soldiers are trained here every year, and they use their skills all over the world. We better behave, because we're under the command of Captain Luke Parker.
Captain Parker! Captain Parker!
Gentlemen.
Sir, what exactly do engineers do in the army?
The engineers allow the army to live, to move and to fight. They learn how to build bridges, create obstacles, breach minefields.
You mentioned bridges. What kind of conditions would they have to build the bridge under?
In almost any conceivable condition.
What? And I take it they're not exactly light, these bridges, as well?
No, the bridges are extremely heavy, and it takes a soldier 10 weeks to learn how to build all these bridges.
Oh, we ain't got that long.
You've not got that long. However, what we do have is a lake that needs crossing, we've got a bridge that needs building, and we've not got much time to do it.
To the bridge!
It's bridge build.
All right.
Get ready for Team Dick versus Team Dom in a frantic race to cross a lake.
Working alongside a highly trained team of Royal Engineers, we must each build a 22-metre-long footbridge.
The first team to finish their bridge and use it to move a casualty on a stretcher from one bank of the lake to the other will be crowned the winners.
There's just time for a few last-minute preparations. Perfect.
We certainly look the part. But will we be able to act it?
Friendly call sign has been in contact with the enemy across the other side of the river. We have been tasked to retrieve the casualties across the river using the infantry assault bridge and extract them to the casualty post. The team that gets their casualty to the Land Rover first wins.
Go! And we're off!
Right, here we go. Hey, go on, buddy. Go.
This infantry assault bridge is a favourite of the British Army. Its brilliantly simple design means it can be built and dismantled quickly in virtually any conditions.
Go, 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 go.
What's happening? Come on, Sweaty, put your back into it.
In 8.
Quicker, go on, speed it up. Go get the next piece.
It's hard work, this.
Each of these aluminium bridge sections is around 4.5 metres long and weighs 55 kilograms.
Don't know if this can last, though. My legs are starting to give way.
It's neck and neck. No slacking, Dominici. Keep going.
Could never be in the army. It's not for me. I'll stick with TV.
The joined-up sections are pushed out across the water and rested on floats.
Down to the back!
We're halfway across, and Team Dom have opened up a small lead.
We've got one whole piece left.
Final piece, final piece.
Dom's still in front, but McCourt's no quitter.
Okay, good. Next piece, next piece.
Come on, they're catching up. Come on. Now, this is where we test out how strong the bridge actually is.
The completed bridge weighs a hefty 278 kilograms, which is nearly 2,000 ham sandwiches with the crusts on.
Shattered.
A stretcher can now be slotted onto the handrails to allow a casualty to be moved safely. My team are first to try out a finished bridge.
It's wobbly. Oh, it's wobbly. Wow, wobbly. Really wobbly.
I'm off.
I'll have to give it everything to get back in the race.
Right, across.
Now for the real test. That really is a real soldier on the stretcher.
Hey there.
Come on, McCall! Run!
We're coming. We're coming.
I'm pushing!
Pushing, pushing.
We're on the home straight. A 20-metre dash to a waiting 4x4. And now there's clear daylight between us and Team Dick.
We did it well, everyone.
It's victory for Team Dom.
I'm absolutely done.
We've lost! We've lost!
Oopsie.
We nearly lost the casualty.
Tell you what, that is the fastest bit of bridge building I've ever seen. Literally, from pieces of bridge to a whole bridge that can take the weight of about 3 or 4 people, all in a few minutes. Now that was a monster build. Right, you can get up now, Jay. Come on.
The bridges might be built,
But the Royal Engineers haven't finished with us quite yet.
Congratulations, Wood. You got your casualty across first. McCaw, unfortunately, your team came last, so there will be a forfeit for you. Dom, your team is dismissed.
Everyone like
McCaw,
Can't afford
what I want
it.
from you is 20 of your finest press-ups.
I can't do press-ups.
Let's go then,
What's
get
going on?
whinging, and let's get these
man.
press-ups done. Come
Can
on.
only do 4.
Let's go then. 1, all the way down. Come on, McCaw, let's go. 2, come on, McCaw, I want more effort than that. Let's go, come on. McCaw, my mum can do better press-ups than that.
We go home now.
So, thank you to our 3 geniuses for some truly epic bridges.
Vitruvius, Albert, Hull, you are all absolute genius. We salute you.
Squad fall.
My idea was the best. No, mine was.
You've got to be kidding. It was mine.